everyone. Hello everyone. Today we're going to talk about slope. Okay. So when you see this sign over here, this sign over here says 14%, 14% grade, next 1/2 mile. So what did this 14% here mean? This 14% means when you're driving, for every 100 feet that you move forward, you're going to rise up 14 feet. So 14 feet divided by 100 feet, that is 14%. So this 14% here is the ratio of this rise over run. So it gives you an idea of how steep is the road, how steep is the mountain, okay, or how steep is the ramp that you go up, okay. So this ratio is kind of important because it measures the steepness, okay. So we give it a name, we call that slope. Slope measures steepness and is equal to rise over run. So notice that rise and run over here, they intersect at this right angle, a 90-degree angle, okay? Rise is a vertical change and run is a horizontal change. So look at the first example over here. We have a line over here. This line over here is rising from left to the right. So let's measure the slope. Let's see how steep is this line right here. So let's just pick any 2 points on this line right here, and we're going to make a right triangle. Okay, so take this point and this point over here, and make a right triangle like this. Okay, so from this point to this point, it go up how many units? Right over here, 3 units, and then 2 more units. So it rises up 5 units. And from this point to this point, you run to the right side, 4 units. 1 unit here, 3 units over here. So total run here is 4 units. Okay. So when you use rise over run, so rise is 5, run is 4. Rise over 5 is 5 over 4. Okay. So this is the slope for this line right here. It is positive, you see, and that actually corresponding to the line is rising from the left to the right. So from left to right, it's going up. Okay. Now, when you assign the sign for rise, when you go up, then rise is positive. When you go down, rise is negative. When you run to the right side, it's positive run. When you run to the left side, it is negative run. Okay. Example 2. In this example, we're giving the coordinates for these 2 points. So let's measure the slope for this straight line right here. Okay. So from this point to this point, how many units you go up? Well, we see that is from the y coordinate for this point is 2. Y coordinate for this point is 4. If you go up from this point to this point, you go up this much, which corresponding to from 2 to 4. So the rise over here, from this point to this point, it is going to be 4 subtracting 2. Y2 minus Y1. So it will be 4 subtracting 2, which is from here to here, which is from here to here. Now, what about the run? From this point to this point, you run to the right side. So it should be positive run. And before the x-coordinate here, it is 3. And here for this point, x-coordinate is 7. The run will be from 3 to 7. So it's going to be 7 minus 3. So this is x2 over here, subtract x1 over here. So this is the run, okay? Now we're going to calculate this. 4 minus 2 is 2, 7 minus 3 is 4. But don't forget, you want to reduce it when possible. So once you get this quotient, if it's possible to reduce it, don't forget to reduce it. So reduce this is going to be 1/2. Okay, it's important to reduce it. Now, from this example, we can actually observe this formula. And if you're given the coordinates of 2 points on one straight line, so the slope formula will be y2 minus y1 over x2 minus x1. In other words, that is change in y divided by the change in x. Notice the change of y should be in the numerator on top. So that's the formula. When you're given 2 points of the line and to calculate the slope, you can just plug in to this formula. Now, for the next few example, we're given 2 points on the line, and we try to find the slope of the line. So this one over here, this 2 point. Now, since we're given this 2 point, we can just go ahead and use this slope formula right here. So let's label this x1, y1, x2, y2. So this will be y2 minus y1 over x2 minus x1. So this will be 4 minus 2 over 7 minus 3. And simplify that, we should get 1/2. So 1/2 is the final answer over here. Now, another way to do this is to, well, some people will say, what happens if I label this x1 and y1 and label the other one here x2, y2? Let's try that out and see if we get the same answer over here. So if we do it this way, so this will be y2 minus y1 will be 2 minus 4. X2 minus x1 will be 3 minus 7. Now the answer here will be -2 over -4. However, if you reduce it, you also get the same answer here, which is 1/2. So it's the same result. So as long as you are being consistent, label this point x1, y1, x2, y2. If you start with the y coordinate at this point, subtract the y coordinate at this point, then you will start with the x coordinate at this point, subtract the x coordinate at this point. Just be consistent, okay? All right, so the result will be the same. Okay, example 2. So again, we're given 2 points on this line right here. We're trying to find the slope for this line that passing the 2 points. So we're going to use a formula. So we're going to have y2 minus y1 over x2 minus x1. Do the calculation. Then this is going to become -8 over +5. Remember, when you have this minus -2, that is going to become adding 2. Okay, so this is 5. This result here cannot be reduced. So this is the final answer for the slope. Or you can leave the negative sign in front of this. So you have -8 over 5. Now notice that what happened over here. If you graph this 2 point, you see the line that passing this 2 point is actually falling from left to right. So the negative sign here indicates the line is falling from left to right. Next example. Now what happened to the slope for a horizontal line? If the line here is horizontal, rise is going to be 0. So rise over run, this ratio, you will have 0 in the numerator. So 0 divided by a non-zero number will be equal to 0. So the slope will be equal to 0. So because slope measures steepness when the line is horizontal, so it's not steep at all, so the slope is equal to 0. So it makes sense. Okay. What about vertical line? Vertical line is like that. Okay. Now, because the line is vertical, the x coordinate is going to stay the same, so it doesn't run to the left or the right. So the run over here will be equal to 0. So you're going to have 0 under in the denominator. So when you have 0 under, the quotient here is undefined, which means it's not a real number. So for vertical line, the slope here it is undefined. Okay. Let's summarize what we have done. So when the line is rising from left to right, the slope it is positive. When the line is horizontal, the slope is 0. When the line is falling from left to right, the slope is negative. When the line it is vertical, okay, think about it is a cliff. It's a vertical cliff. So if it's vertical, then the slope will be undefined. So if you fall off a cliff, then it won't be defined anymore. Okay. Okay. So we can actually make a slope man using this. Okay. So when the line it is falling, then the slope will be negative. When the line is rising, the slope it is positive. When the line it is horizontal, the slope it is 0. When the line is vertical, so the slope will be undefined. And that looks like a face. Let's call it the slope man. Oh, by the way, be very careful over here. So undefined and 0 do not mean the same thing. A horizontal line has a slope to be 0. It is a defined slope. It is defined, it is a real number, and it's equal to 0. However, a vertical line does not have a defined slope. The slope is not a real number. So we say the slope is undefined.